Hello, I'm David Valdés, and I wanted to talk to you today about some scientific notation. Now, here's the formal definition. It is a times 10 to the n such that or where 1 is less than or equal to the magnitude of a, which is less than 10, and n is a member of the set of integers. Now, to break all that down a little bit more simply, a is between 1 and 10, okay? So 1, 2, 3, 9.9999, but not including 10. And a can also be negative, so that's why I use the absolute value bars there to say the magnitude. This just means over here a member of the set of integers. Integers are 1, 2, 3, 4, 0, -1, -2, anything like that. So for an example of something that's in scientific notation, 2 times 10 to the 5th power would constitute a number in scientific notation. Now, before I expand that out and tell you what that is, let's just talk briefly about powers of 10. Powers of 10. Scientific notation takes advantage of powers of 10 to write very large numbers or very small numbers in a nice, concise way. And it's used by scientists often because we deal with very large numbers and very small numbers. So perhaps that's where it gets its name, scientific notation. So let's just take a look at some of the powers of 10. Starting with 10 to the 0 power. Remember that anything to the 0 power is 1. 10 to the 1st power, anything to the 1st power is itself. 10 to the 2nd power, this gives me 10 times 10, which is 100. 10 to the 3rd power, 10 times 10 times 10, okay, which equals 1,000. And you probably already noticed a pattern here, something that's really nice and convenient about using powers of 10. What if I dropped down and said 10 to the 5th power? So if indeed you notice the pattern, you would say, oh, I'm just going to put a 1 here with 5 zeros behind it. Very nice. Okay, so indeed 10 to the 5th power is 100,000. So if I come back to this real quick before I talk about some other powers of 10, this means 2 times 100,000, which comes out to 200,000. Okay, and there's another convenient thing to notice there in your final result. Now, if you imagine 10 to the 15th power or something, this number is huge, right? 10 to the 24th, 10 to the 30th, those are all common numbers in science. Okay, let's take a look not only at the positive powers of 10, but let's look at some negative powers of 10 also. And I'll just put those up here, I guess. I didn't really think about my space too much. Let's start with 10 to the -1 power. Okay, 10 to the 0. 0 is both positive and negative, or neither positive nor negative. I don't know how to think about that. But 10 to the 0 power is always 1. 10 to the -1 means 1 over 10. And if we were to write this as a decimal, it means 0.1. 10 to the -2 is 1 over 100. As a decimal, 0.01. 10 to the -3, 1 over 1,000. Okay. Now, how am I getting the 1 over 10, 1 over 100, 1 over 1,000? Remember that 10 to the -2 means 1 over 10 squared, and there's our 10 squared. 10 to the -3 means 1 over 10 cubed, and there's our 10 cubed right there, 1,000. Comes out to 0.001, and so on. And I'm sure you've noticed the pattern here as well. 10 to the -5th. Instead of writing it as a fraction, let me go ahead and just go straight to the decimal. It should come out as 0.1234 and then a 1. Okay, so something you can say here is that if I started with 1, just the number 1, and a decimal behind 1, The negative power tells me how far to move that decimal to the left. So if I started here, -1 tells me go to the left 1, there's the decimal. If I start with the decimal here, 10 to the -2 says go back 2, so I'd start here, go back 2 places. There's where the decimal starts. Same thing here. 10 to the -3, if I'm starting with 1, 1, 2, 3 places, there it is. And you can see the pattern continue. So let me just do one more example. I'll do it over here. With a negative power, suppose I had 2 times 10 to the -3. Then what that really means is 2 times, I could put it as a fraction or a decimal, whichever one you prefer, whichever one is more convenient. Okay. I'll use the fraction. I like fractions. I don't mind fractions. So 2 over 1,000 equals, let's reduce that to 1 over 500 in the end. Okay. Or if you wanted to look at that as a decimal, it would be, we'll just put it right here. That actually is easier to represent as a decimal because it's in a power of 10. 2/1000, 0, 0, 2, just like that. Okay. So there's the reduced fraction. There's the decimal notation. So with that introduction, hang out with me for another few videos and I'll show more examples of scientific notation.